page is a lot of formulas. And I mean, it kind of highlights the really rough part of the Calc AP test. So most of you have this formula sheet that I gave you guys. I don't remember what day I gave them out, but if you need one, I still have a couple. Nobody in this class got them? No. Oh, all right, I'll print them out today. I gave them to you earlier in the year when we were doing derivatives, if that helps. It's the same one. But basically, there's a lot of formulas you're supposed to know for the AP test. And I don't know why they set up the different AP tests differently. AP Stats, you get a formula sheet and they know which questions you'll be having ahead of time. The new AP Pre-Calc class, I don't know if they get a formula sheet, but I do know that they know which questions they'll be getting on the AP test. But for Calc AB and Calc BC, they give you nothing and they tell you nothing. I'm not sure why. So the only plus out of that is that if we look at the past tests they've given, we kind of know which formulas they have a tendency not to ask questions on. You know, if you ask me what you should memorize, I could kind of tell you how to prioritize it, but you know, you're supposed to know all of these, which is a lot. It's in 6 weeks. So that also brings up, if your goal is to do well on the AP test, because that's not everybody's goal. I mean, I'm not going to try to pretend it is. But if it is your goal to get a good score, I will obviously be teaching you all the math associated with the test, but we don't even remotely have enough time for me to try to go a lot into AP specific things, okay? So I'm sure you guys have seen those study books for other classes. I mean, if this is your first AP class, you probably have it. So there's 3 main workbooks that are pretty popular. There's a Barron's book, which I think is like 18 bucks on Amazon. I think it's like $5 more at Barnes & Noble, but they have them there. So Barron's is one brand that has it for all the different classes. Princeton Review is another one. They have it for all the AP classes as well. And then I think the third one is Kaplan. That's kind of a newer one. Does that sound right? Have you guys ever bought any Kaplan books? Okay. I think Kaplan is that company that has tutoring stores and stuff. But either way, my guess is all of them are pretty decent. I know I have experience using the Barron's one just because we've used it in classes before. It's obviously a big book. Like, it's whichever AP class you're trying to study for, they're all huge books. So for Calc, they have the notes on every topic in here. So like say, for example, if you find that you're forgetting a lot on limits, right? You could kind of just go straight to the limits portion of this to review that. And they have them written out so you can just read it. It's not something where you have to write down notes. It has a bunch of example questions in each topic, and then it has, I think, like 6 practice tests. What I've heard from past students is that the multiple choice questions in this book are more difficult than the real test, which I like, because then that means you're practicing harder questions, and then the real ones feel a lot easier. The free response in these is not as difficult as the real test. So in terms of free response, I generally try to give you guys some free response things as we get closer to the test to try to balance that out. I've got a handful of these, if anybody wants to borrow them too. Obviously, they're not the new ones. I don't think the new one is, what would the new one be? 15th or 16th edition maybe? I don't know if anybody actually bought one. Oh, guess not, okay. But anyway, the editions don't actually change, so I'm not sure why they sell a new one each year. So I have some, if you're welcome, if you wanna check one out or something, you're welcome to it. I also have flashcards that we ordered that kind of match up with the workbook. So I'm assuming the flashcards are, like, what's the derivative of sine, what's the integral of, all this kind of stuff. So if you are a flashcard person, feel free to use those. But either way, it's like 6 weeks away, so it's coming up quick. And doesn't make it any better that the ACT is 3 weeks from today, or from yesterday. So there's like so much stuff going on. And I don't like that they have the ACT that close to the AP tests, because a lot of you end up doing both. So it's kind of rough. Okay, nothing to do with section 8, but I just wanted to talk about that before I forgot it. Well, section 8 covers some formulas we've already done and some that we have not. So we have obviously done the integral of sine and cosine, and I believe I showed you how to find the integral of tangent, but then that's all the farther I went. And so we definitely did not do cosecant or secant. Cotangent was just kind of the opposite of it. The only positive or plus out of this is that they're sort of paired up just like derivatives, where if you can memorize one, you generally sort of know the other one by default. So tangent is negative natural log cosine. Cotangent is the opposite, so it's positive natural log sine. So it's just the opposite things. And same with cosecant, secant, they have opposite answers. So they're not terrible to memorize. But the main focus for today, which you would have not seen before, are the inverse trig integrals. And so here's where I can try to tell you guys to prioritize if you are trying to memorize things. Guaranteed arcsine will be on the AP test. Arctangent is 75% probably. Arcsecant, I have not ever seen on the test. Doesn't mean it won't be on there, but it has not been on the past 20 years, so that's kind of what we're going with, right? But I know these two are by far the most common ones. At the bottom of the page on 6.8, I don't even know why this is here. You do not need to know the double angle identities. So they're from pre-calc. They are not on the AP test. If they ever are needed, they write that formula in the problem. But these are not needed. I have noticed that some answers in our answer key have used these, but you don't need to, so that's fine if you don't. Remember them, it's nothing needed. What I wanted to do today, which in all honesty, went so much worse than I expected it to go in second hour, so I'm hoping it goes better today. Hi. Unless I'm kind of weird to have to check in like 6, 7.
Yeah.
Okay. All right. So all of these questions here, they're not meant to be obvious how you're supposed to do them. And so because of that, I generally wanted you guys to try to figure out how they're laid out. You have, well, it's going to be, oh, the formula's not, oh, perfect. They are on the other page. I didn't know if it was on the back of the page or if it was. So, you guys are able to look at the formulas on that sheet while we're doing these 6. I did write the ones up here that we have not done, so even when we go on to the back side of the page, there's some up here to look at too. So what you have to get good at is you have to be able to look at a problem and try to identify, like its format, like how it's laid out. You obviously should look to see if something is the derivative of something else, like that's kind of an automatic. But then from there, you have to kind of know which one of these it sort of looks like. Including the ones we already know. So like this is just the ones we haven't done yet. Question number 1. You do want to highlight that / know it, because they have a different version of this one on multiple choice every year. Now, the thing that is different every single year is that power that's on the X is a different power every single year, and that doesn't affect it. It would be helpful if you guys actually just like would start watching. So, to help you get started, I will tell you that the cubed on the inside, it could be a squared, it could be a 4th power, 5th power, it's not gonna affect how we do the problem. And that's because a power on the inside of natural log can come out as a multiplier. And so what we're actually gonna do is bring that multiplier out front of the integral, and it's not going to affect the problem. So this will become 1/3 integral 1 over x ln x. Do you want me to give you like a minute to try to look that over to see if you can figure out anything about it before I give you a hint? Because we're at the end of unit 6, like we don't have a ton left of calc, and so you're kind of supposed to be at the point where you guys are sort of self-sufficient. So why don't you look at that for a minute, see if you can kind of figure out what it sort of fits. Look for something that's a derivative of something else. Like that's pretty common.
Yeah, I think so.
Okay, your hint, if you need it, is that this problem is absolutely fits this form. And it's weird. I mean, like, I'm sure that's partly the reason they put this on there every single year is because it's weird, but it shows that you can use logic to try to fit a formula, no matter how strange the answer is.
No. I don't. So I got it to be over you.
Yeah, that was good.
And it's gonna be 1/3 if you over this thing. Is it ln? Isn't that what you do when you get to over you? Yeah. Okay. Three natural
Okay, no, I'm saying.
Well, you wrote ln. that's a U. Okay, I'm looking at it upside down.
Natural law, not like that.
Hey, I saw a lot of people try to pretty much have it figured out already, so that's excellent. The U that you're gonna use as substitution is ln of x, and its derivative is 1 over x. FYI, if anything, we have no way of integrating ln of x. So if you ever see an ln of x in an integral problem, that has to be the U substitution. Because there is no way to integrate ln on its own. But a lot of people kind of got this figured out and kind of noticed it. The reason it definitely looks strange is that the 1 over x isn't written on the top like you're looking for. It's, I mean, like you can't write a fraction on top of a fraction, so they simplify it, which puts it on the bottom. And so it's kind of a disguised version of 1 over x on the top. And so then you get 1/3 integral du over u when you do the substitution. And it's going to give you 1/3 natural log of u plus c, which is natural log of natural log. It makes 0 sense, and that's fine. Yeah, but it's a strange question that they do every single year. So if this was a squared instead of a cubed, your final answer would be 1/2. If this is the 5th power, it'd be 1/5. So that part doesn't affect the actual problem. Yeah. Oh, yeah. I don't know if you guys ever actually use it or not. I suppose from that spot it's easier to turn on. Okay, good. Let's go on to B. Okay, we've got sine of theta over 2 minus 3 cosine theta. Evan, what do you kind of look for? We've got a whole bunch of things in the problem, so what should you be mentally looking for as you spot them?
The sine and cosine.
Good, because they are derivatives of each other,
Yeah.
and so it most likely is somehow going to be associated with that for substitution. Some people in second hour tried to make sine to be the u, which I get it. The reason that won't work, no matter what, is if you look at where the dx and the du and all those are, they're always at the end of the problem, which is the same as the top of the fraction. Your du can never be on the bottom. So if you're doing substitution, your substitution pretty much always is, if you have a fraction, you're kind of almost guaranteed that the substitution is going to include the bottom, because your du cannot be on the bottom. Okay, so if you realize that these are the derivatives of each other, make the bottom u. And what you might want to figure out is, you're going to try to figure out if 3 cosine is u or if the whole thing is u. Because you're never really sure. You just basically try it and find out. Now, do you guys want me to give you kind of a couple minutes on these problems to just try them on your own first before we do them? I'm okay with that, yeah? Okay, good. Yeah, the 2 has to be with it, because otherwise it screws it.
Yeah. Sure.
No, don't write it what I'm writing down. Okay, don't write what I'm writing down. Here's the process you should go through. Like, if you're not sure what should be the substitution, you basically just try it and find out, right? So like, maybe it's 3 cosine. Well, if that's the case, then du -3 sine theta, and I could make that work on the top. So I put a -3 on the top, a -1/3 up front. But then when I actually substitute the things, well, I get du over 2 minus u. Well, that's, this isn't like super clear. This doesn't fit any of the formulas we know. And the whole reason for substitution is that this should look exactly like one of our formulas. And so this kind of tells me that didn't really work correct. If you're really good at if you're really good at integration, you could actually do this one, even though it's not perfect, but we're not going to. And that's because the numerator is actually kind of the derivative of the bottom. Not perfect, but kind of. So what I'm gonna do is, instead of that being the correct u, is I'm gonna make u the entire bottom. And I heard a lot of you trying to figure out which one it is. So just make u 2 minus 3 cosine theta. Make it the entire bottom. And then the derivative of the entire bottom is already what's up on top. Positive 3 sine theta. Wait, did I write that wrong last? Oh no, I didn't have a negative last time. And so my numerator is actually closer now than what it was before. So I kind of fixed that. And then it should be really obvious, once you do your substitution correctly, like, you get exactly the formula you're kind of looking for. So this one is the same as the first box. Oh. What are we doing today? This is kind of a rough day. Yeah, well, I don't want you in here if you're not gonna pay attention. Okay, do you need me to finish this one with you? Good. I wanna move on, so we have more time. I'm gonna skip C because it's exactly like B, so I don't need to like go over that same one. I'm gonna get to D, because that one is definitely not the same as any problem we've done yet today. First thing you guys should do on your own, trying to figure out what should be the u substitution. Now the one tip I have, I see a variable in the exponent. We only have 2 integral formulas that have a variable in the exponent. And so that kind of tells me almost exactly which one I'm trying to use. The e to the u and the a to the u formula on the previous page, those are the only 2 that have a variable in the power. So it's got to fit one of those. Lizzie, what's u?
You? Okay, my apologies. All right, so would you be e to x cubed over 2?
Okay, so if that was the case,
Okay.
so like if you write that down, what would be the derivative of e to the half x squared?
Well, would it just be e to the half x squared?
Correct. It would be basically the exact same thing times that derivative. And so the reason I know this isn't gonna work is because I would need 2 separate e things for that to fit. So u should be, I'm assuming somebody else kind of trial and error figured it out? Or why should we know it's just the power? What else is in the problem? Yeah, there's an x squared, which is kind of the derivative of 1/2 x cubed. So just because of the other things that are in the problem is what tells you it's just 1/2 x cubed for u. X cubed over 2, there's nothing wrong with it written that way, but I think virtually everybody mentally understands it better as 1/2 x cubed. Okay, we are missing a 3/2. So put a 3/2 in and a 2/3 out front. Cindy, how do I go from here? If we did, that would basically just go right back to what we started with. You have the right idea, but you're a couple steps early. Okay, so what should it be? But absolutely, that is exactly what I would do, is look at.
U plus C.
Okay, good. So what should I write down? Should I just write down e to the u plus c?
No, it's like, yeah, 2/3.
Good. So ours had a 2/3, so you have to include that in the answer. And then you would do what you were trying to say, is substitute that. Okay, good. Going on to E. I'm trying to fit in as many of these as I can today. Because we're not really learning something new today, we're just basically practicing more difficult versions of all of them. So I've got integral e to the cotangent of x over sine squared x dx. I will 100% give you guys a couple minutes to try to, I'll say this as nice as I can at this stage. Don't sit there and talk about some other story. Try these problems together. I don't want to give you time to work if you guys are just going to talk about some other stuff. So, some of you are doing a great job at trying these, others are not. Try to figure these out together.
I don't know, the issues with E on top.
Yeah.
With sine square alpha. The integral of cotangent is ln.
But it would have to be,
You can't have a natural out of a negative number, so it has to have that.
Yeah.
You guys are supposed to be deathly silent.
Yeah.
It's from like.
Tommy's got this. Tommy, why did cotangent have to be u? Oh, what did you have as u? Oh, okay. If sine squared was u, then du would have to be 2 sine to the first times cosine. And if that was in the problem, that would absolutely work, but looking at the problem, that's not there. Right, no, that's, trial and error absolutely is how you kind of narrow down figuring things out. Is there any, rather than just calling individual people, is there anybody who can tell me how come cotangent had to be u? Not even looking at the sine square. Why did cotangent have to be u?
Because you should be using
Yeah, it's in the power. So if you have a variable in the power, it has to be one of those two formulas. And so you've got e to a power, so it's gonna be the e to the u somehow. That guarantees this to be u. Go from there. I figured I would do this with you to try to at least start you off, and then try to figure it out from there.
So do you tell us your sign? Du is the ln of sine of u. So how do we make the bottom? It's not like there's not the reverse. Now it's a log. I mean, or you're doing power b. What? Don't you do power b?
But then you also have to square on the table like that. Yeah, like you can't square.
We start there. I divided by sine.
So it would be one of those.
Is that at least me? Yeah. Well, wait, because you normally use multiply by something.
Okay, if we put if we put sine squared, let me start over. I tried telling you guys cotangent was gonna be u. And then that requires you to remember the derivative of cotangent, which was negative cosecant squared. And then having a sine squared in the bottom should kind of trigger something in your memory that sine and cosecant are reciprocal. So even though it's on the bottom, we're not going to use it there. We're going to rewrite it by moving it to the top as cosecant squared. And then to make this correct, put a negative and a negative. And then kind of immediately it fits the e to the u formula. So you've got negative integral e to the u du. Cotangent. Once you figure out u and du, it generally goes relatively quick. But I mean, figuring them out sometimes can be quite hard. On F, what I wanted to point out, we've got a 2 as the base number and variables as the power. That immediately tells me that it's not going to be the e to a power formula, so it's not going to be e to the u. We learned this one on Monday. Monday? Maybe Friday? No, it must have been either Monday or Thursday. We didn't have school Friday. Either way, the a to the u integral is very similar to e to the u, except you have 1 over ln of the base number as a multiplier in the front. Otherwise, it's exactly like e to the u that you have a to the u. I thought this would be a very good problem for you to practice trying to do substitution in your head without actually writing down substitution. Because eventually that's what you want to do, because it's so much faster, saves you a lot of time, a lot of writing. Like, you don't have to do it, but I mean, this one's a good one to practice it because sine and cosine are the derivatives, and they're just like perfect derivatives already. So mentally, you make the u sine it up. See if you can just write the answer. That's kind of what substitution in your head is just being able to write the answer without doing other stuff in between. If you get it wrong, big deal. You erase it and put in stuff. yeah, you would've been right if it was like, cause that's all you. You don't really have to grade, cause you just have to write one over every two. Everything else is the same. Kentucky, you got it? What'd you get? Yep.
2 to the power sine of x over ln of 2 plus c.
Okay, so that must be the formula that's on the other page or something, okay. So the formula I remembered, which apparently is not the one written down there, the one I remembered is 1 over ln of 2. But that's the exact same thing as dividing by ln of 2 as well. As long as you knew sine of x was the u, and you already had a perfect du, there's no reason to have to write down all that other information. You just know that that's u. So in your head, you would say the integral of 2 to the u is going to be 2 to the u divided by ln of whatever number you had, so this case was 2, plus c. And if this is not something you can do in your head, that's fine. It's not like you have to try to do it all mentally. It's just good practice. I mean, like, think about whatever profession you're gonna try to go into. You are not going to wanna sit there and write down every single calculation, right? Like, it might not seem like it right now. This is going to be the easy stuff, right? It's like when you first learned how to add and subtract, you wrote it down. Now you don't need to write down 5 plus 6, you just do it in your head. This is going to be the same. Like, you'll get so comfortable doing this or doing so many of them that you'll just be able to write it up. And you won't have to calculate it, you don't have to write everything down in between. Okay, we'll get to our last problem here, which is the top one on the back page. G, sorry, not H, G. Oh.
Oh.
That's very acrobatic. Owen, first thoughts.
On G,
G. I don't know, what are we looking at first? Obviously at the bottom, because that's pretty much the only thing.
right,
Okay, so my guess is you would probably be looking for the derivative of that somewhere, because that's what we've had so far.
right,
But we don't have an 8x anywhere. If it was just a number that we were missing, that would be okay. You cannot multiply by a variable to make it correct. So this one most definitely will not be a natural log answer because it's not going to be derivative on top, original and bottom. So it kind of looks like it would because that's what most of our fraction ones have been so far. Okay? Anywhere we go from there?
I'm a bit lost.
No, that's fine. What are you trying to look at? I'm just going through the process, not the answer. Are you looking at the formula page?
Yeah.
Oh, no, that's perfect. That's exactly what you should do. Basically, you want to look at the formulas.
Right,
If you know this isn't going to be derivative of original, see if there's a formula that looks like this at least, like in general. Doesn't have to be perfect, but sort of looks like it. Oh, I wasn't expecting you to answer, but if you found one, sure.
maybe like arctan?
That is perfect.
Yeah.
That is exactly what I was gonna point at. Yeah, good call. So arctan, how should I say it? At first glance, the arctan one sort of feels like the natural log one, but there's actually a large difference. So the arctan formula, I'll just rewrite it instead of walking back and forth constantly. Du over a squared plus u squared is 1 over a arctan. Oh, this one's not absolute value. U over a. Okay. So, absolutely, probably the part that drew attention was the fact that you had two things being added. And these are both squared. It's not perfect, because like the 5's not squared. But what we need to do is we need to figure out what was squared to be u squared and a squared. So this is like back when you guys first learned difference of squares. You would have had 16x squared minus 9y squared, and you figured out that 16x squared came from 4x and 4x, and then 3y and 3y. So you're trying to figure out what was squared to be u. And so it would be 2x was squared, and then root 5. And then the reason this will work is because u is just 2x. Like u isn't 4x squared like the other problems we've done. U would be 2x, just because of the way the formula is written. And so du is just a single number. And then I'll also write down a, because we're going to use that for writing the answer. So because du is just 2, this one would work for us, because we can multiply the top by 2, and then that's the perfect du, 1/2 out front. The way that I was trying to explain this problem to you is kind of the way that you have to approach them. Like, you're just going to be given random problems. They're not always going to be grouped together like they're all the same type. So you look at obvious things. If it doesn't fit what you have at first, then you try to look through and see what else may look like it. This one did not have an obvious derivative with it, so that's kind of what led us to the tangent one. Basically just trying things. Okay, now that we've identified the u and the a, we basically could just write our answer immediately. Our answer is going to be 1/2 times 1 over a, so 1 over root 5, arctan, and then the angle on arctan, excuse me, not the angle, but the ratio. The inside information is going to be 2x over root 5 plus c. And I know this is terrible notation. I didn't even write in the u substitution, but I sometimes find that easier once I figured out u and a to just write the answer with that info in. Okay. I will let you guys try to figure out h on your own. We got 7 minutes to do it. And then I'll write the answer up at the very end.